Personal finance practice problem using OneNote. Home cost, estimated increase in price. Prepare to get financially fit by practicing personal finance. Here we are in OneNote. If you have access to OneNote, would like to follow along, you're not required to, but if would like to, we're in the icon on the left-hand side, the Practice Problems tab, down in the 1140 Home Cost Estimated Increase tab. Also note, when using OneNote, look at the Immersive Reader tool. Our presentations will also be in the text area with the same name, same number, but with transcripts. Transcripts that can be translated into multiple different languages and either listened to or read in them. Closing the icon, got the information up top, calculations on down below. We're going to be estimating an increase in a home price using the future value calculation. This will be similar to what we saw in an inflation type of calculation. In other words, we're assuming that the home price will go up over time. However, of course, when we're looking at one item, such as a home cost, the increase in the home cost could be due to other factors than just inflation. It is one of those things that we could kind of compare from the home price, looking at the changes in the prices over time to other items and try to determine, how much of it is due to inflation, which would be the decrease in the purchasing power, and how much is due to other things which typically will be included when you're talking about a home, the location of the home and the things that are going on in the local area with regards to it. Also note that, of course, the home price is typically a large dollar amount purchase for most individuals, and therefore any dollar amount increase or percent increase in the price will have a significant impact in our decision-making process. It's also something that people often save up for. So in this particular scenario, we're going to assume that we have the home cost of the $200,000. We're going to assume that's today. And then we assume there's going to be a 2% increase. That's what we're predicting on the price increase of the home. And we're going to think that we're going to be able to buy in 8 years. So if we were to plan 8 years ahead to think about we're going to be purchasing a home around this point or this place, then first step, we would have to determine the price of the home at this point in time. Next step, we'd have to determine what we think the price will be 8 years from now, which means we'd have to indicate most likely an increase in price, which would reflect at least inflation and possibly more than that. And then we'd have to then think about what our savings side would have to be in order to meet the target that we have now determined is there, taking into consideration time value of money, taking into consideration the loan that we might take out and whatnot once we do that. So first, we're starting off with the $200,000 as the current price and trying to figure out what the actual cost of the home will be at the purchase date 8 years from now. We got the expected annual increase in price, which is 2%, which is a fairly modest increase. Remember that inflation generally is shooting for between 0 and 3%. So if the home price increase just simply reflect normal kind of inflation that the U.S. generally kind of shoots for, then you'd have that modest increase of the 2%. Again, of course, the home in different locations can fluctuate greatly, and all we can do is make our best guess as to what the price will be at a future point in time. And then we're going to take it out 8 years. Note that although we're using a very modest increase here of the 2%, then it should have a fairly significant impact on the increase in the price due to the fact that the price is fairly high for most individual people that are going to be making purchases in their lifetime. So we got the $200,000 here. So this is going to be basically a future value type of calculation. Note that this is a little bit different than most people's first thought as to what a future value calculation will be. In other words, when you think about a future value calculation, how much something will be in the future, the first problem that would come to your mind most likely would be one in which you put an investment down, you get some return on it, and then predict how much money you would have in the future. In this case, we're talking about something that we want to buy in the future, and we're trying to think about how much the increase in that price will go up due to inflation and other factors, so that we can then think about how much money that we would have to save in order to make the purchase in the future. Okay, so let's go down here. Let's do this a couple different ways. We're going to do this with the running balance first. This is a very good way to look at things because it'll give you more than just the answer after 8 years, but also a running balance so you can see the increase in the price over time. And that helps you if you wanted to adjust your plans in a decision-making process like this to see what is happening from year to year. So this would be hard to do by hand, not hard, but long. It'll take a little bit of time to do. easy to do in Excel. We do this in Excel, so if you want to check that out, you can take a look at that and spend a little bit more time building tables in Excel or some other spreadsheet program. We're going to start off with the price of the $200,000 at year 0, and then we're simply going to increase it by 2% each year, compounding yearly. So if we pull out the trusty calculator here and do some trusty calculations with it, 200,000 times 0.02 would then be 4,000 increase. That means that the 200,000 plus the 4,000 would give us the 204,000. We can also get to that 204,000 by taking 1 plus 0.02, which would be 102%, 1.02 times the 200,000. That would give us to that 204 as well. Now we're going to take that 204, multiply it times 0.02. Now we've got a 4,080 increase from 2 to 3. Add that then to the 204,000. That means we expect the price of the home to be 2 years later, $208,080 as opposed to the $200,000 if we were able to afford it today. Then we're going to multiply that times the 0.02. We get 4162. Let's add that then to the 208,080. That's going to mean we have a balance now of the 212,242 at year 3. Let's keep it going. We're going to say times 0.02. We now have an increase of 4,245. We're going to add that to the 212,242. That's going to give us then the 216,486. Keeping it going, we're going to say times 0.02. That's going to give us the 4330. We're going to add that then to the 216,486. That's going to give us our 220,816. A couple more times. We're going to say times the 0.02. That's going to give us the 4,416. About adding that to the prior balance, 220,816. That's going to give us then our 225,232. Two more times here. Two more times. That's all we get to do, and then we have to stop this fun times. The good times will end after that, so enjoy these last two. 4,505 about, and then we're going to add that to the 225,232. That's going to give us the 229,737 about. One more time, last time, enjoy it. 0.02 times 0.02, we get the 4595. Adding that then to the 229,737, we get then the 234,332. So at the end of the 8 years then, it's significantly higher, even though there's a 2% increase, which is fairly low. It's at the 234,332, as opposed to, if we can afford it today, the 200,000. And again, you can see how the increase is working the way we're doing our calculation here. So we can also do that calculation using a future value formula here. This will be an Excel formula. So we do this in Excel if you want to take a look at it there, but we'll just outline what the formula will look like here. And we're going to say this will be equal to the future value. Notice I have a negative here. You have to have some negative in the function, or else the result will be a negative. You could put it in the present value section, in other words, in front of this item, but I like to put it in front of the FV, which may not be the most proper way to do it, but the way that I kind of like to do it. So negative future value, brackets, we're going to pick up the rate. The rate you could type in there at 0.02, but I think it's better to pull it in from your data set. That's why there's a cell reference here of the 0.02, which is drawn from our data, comma, number of periods. The number of periods would be 8 years. Once again, we're not typing it in, but pulling it in from the data, which is good Excel practice. Payment, there is no payment because this is not an annuity. We will look at annuities in future presentations. Not an annuity here, though. Therefore, 2 commas to skip that one. Then we're at the present value, our starting point. The starting point then is the 200,000. That's our starting point. Closing that up will once again give us the result of the 234,332. Same result we got up top. Then we can do this with the mathematical formula, which is a straightforward mathematical formula this time. We're solving right for the future value, so it's going to be equal to the present value times 1 plus r to the n. And I'm going to put this in a table format. You can plug in the numbers here. The present value would be 200,000 times 1 plus r, which would be 2%, or 0.02, to the power of n, number of periods, which would be 8. Then solve for it algebraically. I'm going to put it into our table. I think it's good practice to kind of see something in a formula basis, put it into an Excel table, or any kind of table, just to visualize how to put the tables together. This will be similar to what you might see in, say, a tax return format when you take an equation, put it into a table, or in a financial statement type format. I'm going to take the two primary components of this calculation, which is the present value times 1 plus r to the n. I'm going to put them in the outer section of the table in any more detailed calculations, such as the 1 plus r to the n. I'm going to put inside as a subcategory indicated with colons, and that it's an inside category and with an indentation. So we're going to start off with the present value. There's the 200,000 present value. Then we're going to say 1 plus r to the n periods. This is going to be a subcategory indicated by the colon, which is similar to financial statement kind of presentation format oftentimes, meaning we're going to pull this into the inside column and have a subcalculation, which once ended will then be pulled out into the outer section here. So then we're going to say that we have the 1, that 1 right here, plus r. R is going to be the rate of 2%, and that's going to give us the 102. Let's plug that in the calculator just for the fun of it. Notice that that 1 could be 100%, so it's just this different formatting. 1, and then the 2 could be 0.02. That would give us 1.02 or 102%, depending on the format that we want to present that number in. Then we're going to take that to the n periods, to the power of n, to the power of n. And n happens to be 8, so to the power of 8. So to do that, we need a trusty calculator that has the ability to do that. So my calculator doesn't. So this calculator doesn't, so I'm going to go to the scientific calculator. Let's do some scientific calculation. So we got 1.02, and then we're going to take that to the xy, which is the caret of the 8. And that'll give us about 1.1716594 about. And so we're going to say, okay, let's go ahead and bring that back to our normal calculator. So it's small calculator instead of the giant. Those scientists have to lug around that big calculator. So then we're going to say that we have then, multiplying these out of 200,000 times the 1.1716594 about, and that's going to give us about, let's do it one more time. Hold on a second. One more time. 200,000 times 1.1716594 gives us about the 234,332 about. And that's because this number is rounded here. If you were to do it in Excel, it would pick up the full number no matter how many decimals you happen to display. If you're using tables, then note that tables will use rounding, and we will see that shortly. We'll see that now. So we have the tables. Let's do it with the tables then. The tables are something that you probably wouldn't do in practice because you'd probably be wanting to use Excel. I would recommend Excel or some spreadsheet program in practice in conjunction, or the tables here in conjunction, the future value function in conjunction with the running balance. I would try to do a running balance whenever possible. It's quite easy to do even with a lot of periods in Excel, and then combine that with our future value or present value or time value of money calculations. The tables are of course useful oftentimes in school settings where they want to take away the calculator and Excel and make you do this without all the fun stuff that you normally get to do it with, like if you in normal times. So then we could do this with the tables. So we're going to say that we have the 200,000 and then the amount from the table, which is going to be the table we're looking up, making sure that we have the proper table. Remember, there are 4 tables if you're in a test situation, 2 present value tables, 2 future value tables. They both have an annuity table and a non-annuity table. So we have the present value annuity table, the present value non-annuity table, the future value annuity table, the future value non-annuity table. We are looking for then the future value non-annuity table. And so if we go down, here it is. We're looking 2%, 8 periods. These are yearly bases and yearly percents. So 2%, 8 periods, 1.171. So there's the 1.171. If we take that with the trusty calculator, 200,000 times 1.171, we get then the 234,340. Let's do that one more time. 200,000 times the 1.1717. I missed 17. And that's the 234340. So there we have the table. Now note that this amount in the table, this 1.1717, is rounded to 4 digits. And up top here, this is basically the same. This is how you create the table. Here's the full decimal. This isn't the full decimal. It goes on past this. But you can see it goes past 4 digits. Therefore, they had to round to the 4th digit. That will make a difference then in the actual calculation, 234,332 versus 234,340. That difference usually is immaterial for decision making, because obviously this is an estimate in our scenario anyways, and we're estimating an increase, so it's a small dollar amount for our purposes, not going to have an impact on our decision. However, if you're in a test situation, they could take that difference and force you to use the table. In other words, if you use the table, you would come up to the 234,340, even though that's slightly not exactly correct. If you were not to use the tables and somehow use the calculator when they told you not to, then you'd get the 234,332, and they can basically test whether or not you use the method that they wanted you to use by possibly taking advantage of that rounding difference. So just keep that in mind if you're going into a test situation, or if you're going into a problem and they give you multiple answers that are within like $1 of each other. That wouldn't make a difference, those differences in amounts in real life for most decision-making processes where you're projecting into the future, but it can be a way that they can kind of force you to use the method that they're trying to get you to use.